F4U Corsair without myths. With both the speed, firepower, and systemic warfare of the United States, he broke the advantage of Japanese aviation. From Solomon to Okinawa, the evolution of a fighter jet that changed the rules of combat. Forever. The history of any legendary military machine is inevitably overgrown with myths. In the case of the F4U Corsair, the nickname Whistling Death turned out to be the most tenacious. In the Russian-speaking space, it is often turned into the Bird of Death and attributed to Japanese pilots, who allegedly used this name in horror. The picture sounds cinematic. The proud samurai in the cockpit of Zero hears the approaching whistle of the giant R-2800 engine and realizes that now his life will end. But when you start checking the sources, the myth crumbles. Firstly, there is no mention of such a nickname in Japanese memoirs or in documents of the Imperial Navy and Army. Archives, veterans' memoirs, and battle reports are silent. Where names are found, the Japanese more often recorded simply Sikorsky, according to Vought Sikorsky, which originally produced the F4U, or used dry designations. The new fighter of the U.S. Navy. There was no poetic fear in the spirit of the Deathbird. Secondly, the nickname Whistling Death first appeared en masse not in war reports, but in the American press and Vought advertising booklets as early as 1944-45. The advertisers cleverly seized on the characteristic whistle of the Corsair. The sound was created by air passing through the air intakes and cracks in the wing structure. On the ground, and especially during a dive, this whistle was clear. But in combat, pilots often did not hear it at all over the roar of the engine and the chaos of radio conversations. Thirdly, the legend of the fear of the Japanese itself turned out to be convenient for post-war mythology. In the 1950s and 60s, when World War II was being actively romanticized on television and in magazines in the United States, Whistling Death was presented as a name given by the enemy. The story fit beautifully into the images of the Cold War. American technology was so excellent that even the enemy was afraid of it and recognized its nickname. This is how the myth became entrenched in the mass consciousness and still walks through books and the internet. But if you look at the real numbers, it becomes clear that Corsair did not need marketing decorations. He has more than 2,000 confirmed aerial victories with a loss ratio of about 11-1. For comparison, the Japanese Zero in 1941 was a symbol of technical superiority, but by 1943 its design was no longer pulling against Corsair and Hellcat. The main reason for the fear of the Japanese was not the mythical whistle, but the speed, armor, and firepower of the new fighter. It is important to understand the context. When the Corsair appeared in the skies of the Solomon Islands in February 1943, Japanese aircraft were still holding out. But by the end of the same year, the loss of experienced pilots, lack of fuel, and worn-out equipment began to affect. At that moment, the Americans were massively commissioning the latest machines, and the advantage became overwhelming. Hence the feeling of the Corsairs destroyed them in a matter of months. In fact, it was the result of accumulated factors, and the F4U became just one of the symbols of a turning point. Thus, the legend of the bird whistling death is more a product of journalism and advertising than military reality. The Japanese pilots did not call him that, and the fear they felt was explained not by the mystical whistling, but by the harsh arithmetic of combat. In the sky, outdated Zeros and exhausted pilots faced off against a new machine that flew faster, hit harder, and was covered by a whole system of radar, aircraft carriers, and mass training for Americans. The myth is beautiful, but the truth is much more interesting. The F4U Corsair became a legend not because the enemy dubbed it with a creepy nickname, but because it really changed the course of battles. And that's why dozens of stories have grown up around him, because dry numbers and tables rarely excite the imagination, and the word death in the title works much more effectively. The design task sounded audacious. To create a fighter for the fleet that would fly faster than 400 miles per hour, rise like an elevator, dive like a stone, and at the same time land on a short and forgiving deck. Vought went straight to the goal and put a Pratt & Whitney R-2800 double Wasp star in the nose of the aircraft, a legendary engine with a capacity of over 2,000 horsepower. A huge stepper propeller required a gigantic diameter, and a gigantic diameter required high landing gear struts, which turned into a recipe for disaster on an aircraft carrier. Therefore, the wing was bent down like a seagull, and then up again. The brake made it possible to install short and strong struts without the risk of snagging the deck with a screw, reduce the resistance of the wing assembly with the fuselage, and gave the Corsair a recognizable profile. The first experimental XF4U-1 flew in 1940 and immediately showed what the whole adventure was about. Speed at the level of racing cars and inhuman acceleration in a dive. But the devil was in the details. A long nose covered the horizon during landing. An early birdcage lantern provided a narrow viewing slot, and rigid shock absorbers transmitted shock upon touch, artfully turning each landing into a galloping goat. If the gas was released too early, the plane would nod off. If it was too late, it would jump up and go to the second one. For the deck crew, this meant one thing. Until the car was tamed, the risks outweighed the benefits. In parallel, purely aerodynamic surprises surfaced. There used to be a flow stall on the right wing, and at a critical moment the plane would suddenly nod and crash, which is like death on a glide path. The cure turned out to be simple and clever. A small triangular strip was placed on the edge of the right wing, a bar that artificially triggered the breakdown a little earlier and more predictably, aligning the behavior of the left and right half wings. The cracks and seals were improved, and mechanization was brought to life. At the same time, the brakes were tightened, the dampers of the racks were adjusted, and in some batches the height of the pilot's seat was changed to improve visibility in the last phase of the approach. Shipboard life required not only hardware, but also a new manner of piloting. At first, the American Marines were based on the shore, and the more obedient F6FS dominated the naval decks. The British deck school came into play on time. The pilots of the Fleet Air Arm taught the Corsair to enter not in a straight line, but along a curved glide path with a constant turn to the left, keeping the nose to the side, and seeing the deck to the left of the long hood. This arc made it possible to control the movement of the ship, the landing marker and its angle until the last second. For the cramped British hangars, the wingtips were also shortened, and strict discipline of finishers and limiters was practiced on the deck. By the middle of 1943, the British were confidently putting the F4U on aircraft carriers, demonstrating that the problem was not with the damn plane, but with the algorithm. The designers moved the evolution of the series in parallel. The early F4U-1 with a lattice lamp was replaced by the F4U-1A with improved glazing and a raised seat, which dramatically increased the chances of seeing the ship before the ship sees you. There were shovels, wide propeller blades for better power takeoff on the run and in the set. The F4U-1D version brought standard launch rails for NAREs and an increased bomb load, turning the fighter into a universal striker. The F4U-1C modification with 4 20mm cannons proved itself in attacking ships and fortifications, although recoil and ammunition required different tactics. By the end of the war, the F4U-4 came with a redesigned engine and water methanol boost, which knocked out several more tens of miles per hour from above and shortened the climb time. Armament of 6 Brownings. The .50 caliber remained the hallmark of early cars. These machine guns were reliable, and the ammunition allowed for long-range combat. However, childhood illnesses appeared in early batches. The shaded areas of the wing cooled the belts and boxes, the grease thickened, and delays occurred during active maneuvering. The engineers added heaters, casings, changed the installation angle, and the guns started working like clockwork. At the same time, the suspensions were reinforced, so that the cargo would not walk during a dive, because speed at all costs worked only where the airframe could withstand a real combat load. The settings of the engine and the propeller pitch control system required culture from the pilot. Putting the gas on the glide path too early broke the speed and angle. Too late gave a harmful jump. Updated shock absorbers and a well-adjusted approach curve reduced the risk of a goat, and proper operation of the flaps and revolutions kept the aircraft tight, without parasitic fluctuations. At the same time, they rethought the ventilation scheme of the engine niche. With the blinds fully open, early cars caught buffeting, which hit the aiming. The modified louver sections have removed vibrations in key modes. The production program expanded to cooperation. In addition to Vought, Corsair was produced by Goodyear, FG Index, and Brewster, F3A. The licensed cars differed in details, but in total they provided the volumes for which they were betting on the monstrous R2800. This was important not only for frontline saturation. The more planes with the same maintenance logic go into parts, the faster experience accumulates, and the faster minor defects that cannot be caught in the laboratory are identified. The learning curve went down sharply after technicians and pilots began exchanging field checklists. Where to adjust the cables, at what speeds it is better to release the landing gear and flaps, how to adjust the sight to their preferences. Speed remained the core of philosophy. In aerial combat, the Corsair gained the advantage of the energy upper floor. It entered the attack from above, used the advantage in acceleration dynamics, fired a short burst, went up without lingering in the plane of maneuverable combat, where the Light Zero would have a chance. This hit-and-run doctrine was not a whim, but an approximation of aerodynamics to the reality of the Pacific War. Dense cloud layers, ragged orders of ships, long crossings. Where there is an opportunity to maintain speed, there is life. Speed at all costs was a survival strategy, not an advertising slogan. Still, it took time to get to the deck of the United States. The Navy preferred Hellcat as a more genial textbook for the average pilot. And during these months, Corsair honed his character in the Marine Corps Aviation and the British. When the complex of improvements to the equipment and piloting techniques developed into a stable system, there were no obstacles left. The machine, which was born as a record-breaking sprinter, turned into a mature deck fighter and striker, and its taming curve became a textbook for the interaction of designers, testers, and combat squadrons. That's how the image was formed. Not a miracle weapon that fell from the sky, or a moody monster unworthy of a deck, but a high compromise of engineering. The broken wings saved the struts in the pilot's life. The powerful engine dictated the tactics of war from a position of strength, and adjustments that at first seemed like small things. The bar on the wing, the elasticity of the struts, the shape of the lantern, determined the statistics of the battles. The stories of whistling and defiance sound louder, but the real romance is different. The birth of the Corsair is about perseverance in nuances, where every degree, every inch, and every click of the trimmer add up to the very reserve of speed that saves the crew and breaks the will of the enemy. The continuation logically leads to a baptism of fire. How the Marine squadrons transferred this philosophy to the skies of the Solomon Islands, turning the High-Speed Design Bureau project into applied dominance at the front. The transfer of the aircraft from the drawing paradise to the sticky air of the South Seas took place in February 1943. When the Marine VMF-124 arrived on Guadalcanal. Here, for the first time, the F4U faced the full reality of war. Coral runways, sweltering heat, dust, malaria, and an opponent who, after a year and a half of campaigning, was used to winning. A6M0 circled in this sky. G4M Betty torpedo bombers crawled over the waves. D3A Val dive bombers searched for ships off the coast. In such conditions, the engineering formula of speed at all costs turned into a daily survival tactic. The pilot's first discovery turned out to be simple and tough. If you get bogged down in a horizontal carousel, sooner or later Zero will take its toll. It turned out differently to win. Keep the height, come from above, hit in short bursts and go back to the vertical. The Corsair held its energy better than the enemy. He could dive, accelerate quickly, shoot, and hide again on the top floor. Where Zero won at low speeds and tight turns, the F4U imposed a dynamic fight, turning the collision into a series of one-time strikes. Guadalcanal was a school of improvisation. Coral chips clogged filters, cameras burst under load, and evening landings turned into a risky attraction. The sun went out into the ocean. The strip shimmered with kerosene spots, and every goat threatened to overturn. A broken wing saved the struts. Huge tires suffered a blow, and 6 Brownings erased doubts. Any Zero who missed the attack paid. But even with this technique, the key to dominance lay in organization. Fueling without fuss, tight radio discipline, bundles of pairs and fours, predetermined heights and sectors. March and April brought the first serious landfills over Kolombangara and New Georgia. The Japanese continued the Tokyo Express, night flights of destroyers to the islands with people and cargo. And during the day they covered the crossings and bombed Henderson Field. The Corsairs covered their own convoys, met raids, and hunted the baddies, which were deadly with torpedoes but vulnerable on the way out. The squadrons worked out the division of roles. The leaders with a clean wing held the upper stage. The wingmen with outboard tanks patrolled below, intercepting those who broke through to the ships. We also learned more. To fight with a short breath, without getting stuck at the bottom, where Zero made us pay for every mistake. By May, it became clear that Japanese pilots make mistakes more often. The elite of 1941 to 1942 was worn out by the continuous war, and the replenishment did not have time. Guadalcanal has become a meat grinder of preparation. The Americans, unlike the enemy, could afford hours of training right in the combat units and ruthless selection. Corsair disciplined itself to implement the R2800 engine, precise operation of the propeller pitch, careful throttle control, and a cool head at the moment of attack were required. The units worked out simple but crucial rules. Do not lose altitude. Do not chase easy prey down. Do not shoot for more than 3 seconds. Keep a couple in sight, not on the walkie-talkie. The summer of 1943 brought the fighting to Rabaul, the main Japanese fortress on New Britain. A dense mix of Army and Navy aircraft was based at Lacunaire and Guadalcanal airfields. A-6M, Ki-43, Ki-61, bombers, and seaplanes. The logistics of the semi-empire were drawn here, as well as Allied raids. The Corsairs escorted the Dauntless, Avengers, and Lightning ships, and also performed sweeps to clear the airspace before the strike groups approached. Now it was necessary not only to shoot accurately, but also to stay ahead of the enemy's thoughts, to guess the direction of the interceptors' ascent, the time of their recruitment, and the exit corridors. Rabaul taught savvy. The air defense system operated in tiers: small caliber batteries along the coast, medium caliber at altitudes, searchlights and warning radars. They had to enter from unexpected directions and at different levels, splitting up groups in order to intercept the Japanese where they least expected. The leader cut through the cloud layer. The slave held a position half a body below and behind, providing a cross-view and insurance. The first minutes after entering the zone decided everything. Either a favorable geometry was imposed, or a viscous fight began over the bay with islands of fire, where every second deprived speed and chances. Escorting bombers required a different psychology. Bombers live by the speed of the train and the schedule, and a fighter in such modes is boring and dangerous. The advantage is lost. The medicine is separation and barrier protection. Some of the pairs were sitting 3,000 to 5,000 feet above and slightly ahead of the formation. The other covered the tail sector. The third remained free hunters, ready to disrupt the attack even on approach. When the Zero tried to enter from below and behind in a classic slide, the Corsairs crashed into a short burst from the top step and broke off the attack without descending into the air defense zone. By August and September, the combat diaries were filled with dry language. The escort went according to plan. 4 baddies were intercepted, 2 were shot down. There were no losses. Such prose is the recipe for a strategic victory. War is not about continuous duels of aces, but about keeping the pace. The Corsair fit the pace perfectly. Durable, fast, tenacious, with a decent radius with an outboard tank, and a character that pushed for the right decisions. He loved the height and the clean wing, hated the prolonged turns near the ground, asked for energy savings, and rewarded those who listened. The Marine Corps as an institution added stability. In the VMF squadrons, flight discipline was combined with simple but ironclad rules. Do not argue with a gun. Keep in formation. Do not act like a hero if you have lost the lead. And do not rush down for an easy victory if a threat is brewing. Above. On paper, such rules are boring, but in practice they turn pilots into a team, and airplanes into an instrument of collective superiority. When the squadron acted as one unit, even a strong individualist at Zero turned out to be superfluous. He hit the void while looking for his target, and a cold response came from above. By the end of 1943, the front line had shifted to the northwest, and Rabaul, until recently Grozny, was virtually isolated. It was not a miracle of a single machine, and certainly not the result of 3 months of magic. This is the result of accumulation. Training, radars, logistics, intelligence, tactics, and yes, speed translated into initiative. The Corsair became a symbol of this accumulation, not because it was the only winner, but because its appearance coincided with the moment when the Allied system started working like an orchestra. Every instrument is in its place. Every beat is adjusted, and the melody of victory is already audible. Successes had a price. In the field logs, there are names and notes: did not return, disappeared in the clouds, last seen on a turn to the sea. No amount of speed canceled out the accidents. The failure of the fuel system, damage to the radiator, the fire of his ship, which the fighter entered at the wrong angle. But the statistics were stubborn. For every such line, there were dozens of sorties where the Corsair was just doing its job, covering, disrupting the attack, returning the blow, taking home those who were not pulling due to damage or fuel. The outcome of 1943 on the Solomons and around Rabaul can be formulated as follows. The F4U underwent a baptism of fire, confirmed its suitability as a cover fighter and a sweeper, taught pilots the discipline of energy combat, and learned how to live in a tough environment. He did not destroy the enemy's aircraft in 3 months, but helped create the conditions under which the enemy began to lose systematically for the first time. Then a new act will begin. 1944 to 1945, when the Corsair will mature into the role of a universal drummer and a full-fledged deck fighter, and its speed will become not only a way of salvation, but also an instrument of pressure on the entire operational picture. The beginning of 1944 was the moment when the Corsair finally moved from the category of fast but capricious novelty to the class of fleet support vehicles. Landing problems were smoothed out by practice and improvements. The fighter confidently landed on the decks, and the British experience of the curved glide path was fixed in the training maps. But the main change was not about the deck, but about the task. Where in 1943 the priority was the high-altitude upper floor and the hunt for interceptors, in 1944, the Corsair increasingly carried bombs, missiles, and napalm, turning into a universal striker who simultaneously knows how to meet the enemy in the sky and destroy his airfield on the ground. The evolution of modifications has consolidated the turn. The F4U-1A with improved visibility and softer working struts became the base. The F4U-1D added a suspension for large bombs and guides for NAREs. The F4U-1C with 4 20mm cannons provided a toothy option for hitting ships and fortifications. By the end of the war, the F4U-4 arrived with an upgraded R-2800, which gave a higher ceiling, better climb rate, and a chance to impose a battle on its own terms, even when encountering the surviving, fresh, enemy fighters. In practice, it looks simple. A flight to sweep the airfield, a candle up when interceptors appeared, a short queue, dropping bombs on a taxiway or fuel depot, leaving its speed while the anti-aircraft guns were still looking for corrections. The major operations of 1944, Wake, Marshall, Marianas, the crash of the Japanese carrier aircraft, required fighters to play a role that had previously been considered auxiliary, not only to cover, but also to destroy infrastructure. The Corsairs went out ahead of the bombers, cleared the sky, and immediately reset the runways, shooting parking lots, tanks, and air defense positions. Maneuverability at low altitudes was inferior to lighter machines, but the strength of the airframe and power made it possible to withstand fire and return with holes that on another type would have ended up forced onto the water. NAR missiles were among the first to be used systematically, against supply barges, coastal batteries, and tankers in bays. In the reports, the dry formulas, "targets suppressed," meant a breakdown in the pace of the Japanese defense, followed by a loss of the ability to counterattack. At the same time, the military biography of the Night Corsair was formed. Radar variants with an outboard radar in the fairing, F4U-2 family, later F4U-5N, closed the gap between searchlights and ship radars, intercepting night raids of concern and reconnaissance on seaplanes. Night hunting required a different psychology. Patience, precision, the ability to keep speed near the edge of the dump, without losing the target against the background of the sea or island lights. These crews rarely got into the press, but it was they who shortened the life of Japanese night raids, closing the last gap of time for the enemy. From the end of 1944, the center of gravity shifted to the Philippines, and then to Iwo Jima and Okinawa. Here, the Corsair became the face of the near umbrella, the barrage caps that hung between the fleet strike group and the enemy's approach. Against kamikazes, combat arithmetic without romance was needed. Many pairs at different levels, strict sectors, lightning, fast interception when a mark from the radar screen turns into a dark dot above the horizon, and in a matter of tens of seconds, into a burning ball at the edge of the waves. The speed and rate of climb gave a chance to intercept before diving, a cannon machine, gun salvo, a chance to complete the attack in one precise burst, without knocking down the sight of the ship's air defense. Yes, both the Hellcat and the Capital anti-aircraft guns did a huge part of the work, but it was the Corsairs who often closed the last second when delay equaled hitting the deck. The role of the drummer in Okinawa was particularly grim. There was a lot of work. Cave positions, concrete pillboxes, cave ammunition depots, cannons disguised as rocks and bushes. The Corsair brought an unpleasant mix to the enemy at low altitudes. More accurate than a dive bomber, faster than an attack aircraft, heavier than a clean fighter. Napalm, time bombs, rockets, all this, combined with spotters and naval artillery, turned island castles into ruins, and attempts at nighttime barge crossings into glowing trails of oil and wood chips. The conveyor of sorties exhausted the crews, but at the same time removed the enemy's systemic ability to accumulate power in the area. Every day began with uncounted trunks, destroyed road forks, and empty tanks. The symbolic arc of speed at any cost was replaced by initiative at any cost. Now speed was not just a guarantee of survival in aerial combat, but a time management tool in the theater. To take off quickly, to get there quickly, to quickly drop the interception, to quickly destroy the node, to quickly return for a new burden. In this metronomy, Corsair turned out to be ideal. Ahead of them were reconnaissance and an electronic grid, followed by mopping, up fighters, followed by strike fighters, and again fighters, in case one of the opponents still breaks out to intercept. Flight shifts, technical inspection, suspension of weapons, refueling. Everything was spinning like a factory line. The smoother the line worked, the less often the enemy showed up above the warrant, and the fewer ships went to repair. By the end of the war, Corsair had accumulated accounting figures that looked weighty even without advertising nicknames. Thousands of aerial victories, tens of thousands of combat missions, tens of thousands of tons of bombs. But these numbers are just shadows of the process. The real transformation was that the fighter ceased to be a hero of duels and turned into a node of a large system. Radars, search and strike groups, aircraft carrier formations, repair squadrons, fuel and ammunition logistics, training centers. The Corsair fitted into the system at all levels. From the training class, where the cadet learned how to oblique glide path and shoot in short bursts, to the operation headquarters, where flights, tons, and time of approach were counted. This change of role was reflected in the post-war fate. The machine, born as a record-breaking interceptor, became the benchmark for a multi-purpose deck-based workhorse, extending its career in Korea and in a dozen foreign air forces. Versatility turned out to be not an accidental assembly of options, but a consequence of the basic architecture. A sturdy wing, a powerful engine, and energy, tactics that rely on speed as the main resource of combat. Where war required flexibility, Corsair provided it in abundance, and therefore lived up to the jet age, retaining its meaning while other piston veterans went to museums. The years 1944 to 1945 were a peak in intensity and a moment of strategic maturity. The Corsair no longer argued the right to the deck and did not argue with the legends. He just did his job. He covered the sky, destroyed airfields, extinguished batteries, intercepted kamikazes, and returned to the ship with another batch of splinter marks and soot on the wings. This is how the role of technology in war is changing. From a poster boy, it becomes a force routine, and it is this routine that breaks the enemy. The next step in history is to understand why Japanese aviation was bursting at all seams by this point. From training and fuel to tactics and management. That's where the logic of the peak leads, and that's where the full scale of the changes that Corsair helped bring to the finals will become visible. If we discard the cinematic brilliance of superplanes and deadly nicknames, the picture of the collapse of Japanese aviation looks like a slow but inexorable convergence of several causes into one turning point. Planes, pilots, fuel, factories, radars, doctrine, logistics are all links in the same chain, and each is cracked in its own way. Corsair became a symbol of the second half of the war because it ideally stood at the top of this pyramid. Fast, tenacious, built into the system. But it wasn't just one wing with a white star that broke the enemy. It was the totality. The first link is personnel. The Empire entered the war with an elite but thin layer of outstanding pilots. The training pipeline was designed for individual training, not for a mass war. Long courses, high demands, the cult of aces. In 1942, the elite burned out in continuous operations, and it was they who should have become the backbone of the instructors. Instead, it was worn out on the front line, patching up the holes in the battle formation. The result is natural. By the end of 1943, the recruits were coming into service with a sharply reduced raid, and minimal elaboration of the tactics of the group. On paper, the Aviation Regiment was listed as complete, but in reality, it was a set of individuals who were not ready for high-speed combat, radio interaction, and layered defense. The second is fuel. The oil map of the Pacific Ocean is merciless. Without the crimson arrows of convoys from Southeast Asia, the Japanese engine does not turn. The U.S. submarine war tore up the arteries, tankers died on the crossings, and what reached was split between the Army, Navy, and industry. Aviation gasoline is good not only for the number of octanes but also for its availability. There were few of them on the front line, and these few were distributed so that they could take off in a general formation at least once. Bottom line, less training, less fighting, by the rules, more lottery. Even the excellent late fighters performed worse simply because the pilots did not live the necessary hours in the air. The third is industry and quality. The Empire was able to create excellent machines in terms of ideas. Ki-84, N1K2J, modified A6M later series. But in reality, the serial numbers came with a drop in build quality, fluctuations in the strength of parts, and the vagaries of engines. Raw materials were more expensive, alloys were poorer, and there was more waste. This is not visible in the performance tables, but it is felt during takeoff. Overheating, vibrations, floating revolutions, sudden failure of the oil system. When the enemy is flying on an R-2800, configured according to the textbook, and you go into battle on the, as it turns out, engine, the difference accumulates faster than you want to believe. The fourth is doctrine and organization. The concept of the Kantai-Kessen, a decisive general battle, psychologically supported the bet on a heroic episode, rather than on the everyday mathematics of departures, replacements, and repairs. A lot depended on individual skill, on strong-willed attack, on fighting spirit. For the Allies, the bet went the other way. Into the system. Radar, guidance service, echeloned air defense, standardized procedures, crew rotations, leveling the level of average pilots, not pyramids of geniuses and novices. The result was expressed in rhythm. For some, the war went according to schedule, with morning caps, afternoon sweeps, and evening strikes. For others, when it succeeds, and how it turns out. Fifth, tactics and communication. Japanese radio stations were often inferior in reliability, and radio discipline was inferior in pedagogy, where the four allies worked as a single organism, leading the enemy to angles and verticals. Many Japanese units retained the inertia of a tight link, dependent on visual contact and the personal initiative of the leader. Against high-speed energy combat, this resulted in the battle falling apart into several duels, each of which was decided by an advantage in recruitment, diving, and stability at high speeds. And while one daredevil was squeezing everything out of the zero on the small ones, a couple of heavy ones with a short burst were already falling from above. The sixth is constructive philosophy. The success of the early A6M gave rise to the temptation to keep the concept pure. Lightness at any cost, maneuver at any cost. But any price in the second half of the war proved to be unaffordable. Without armored armor and self-sealing tanks, survival dropped sharply. Encountering a six-barreled pocket of hell on the enemy's wing turned even small damage into a fatal fire. Attempts to strengthen the defense were delayed. The advantage in radius and turn no longer decided the outcome when meeting with an opponent who imposes vertical. Boom, zoom! Short contact, and going up. Seventh, operational geography. The isolation of Rabaul, the compression of the ring of bases, and the change of initiative in the air and at sea, turned Japanese airfields into besieged fortresses. Every lane is under a gun. Every warehouse is under a bomb. Every platform is under a rocket visit. In such conditions, even the presence of airplanes did not guarantee their timely use. The weather windows, fuel windows, and safety windows shrank ridiculously. Any delay, and someone else's Jeep is already moving across the sky, and your cars are fueling in the open under the Corsair's U-turn. The eighth is a psychological breakdown. When experienced pilots are knocked out, and recruits see 7 out of 10 returning, or even fewer, fatigue increases, and the willingness to take risks at any cost increases. Kamikazes have become a symptom, not a cure. It was an attempt to turn a lack of skill and technique into an excess of determination. But determination does not create a radar field, does not repair engines, does not stack logistics, does not teach a couple to work on breaking sectors. It only reduces the time of the battle to a moment in which the stats still have time to say their say. The ninth is learning asymmetry. The United States and its allies have training centers, aviation schools, simulators, and a winning cascade of experience, from veteran instructors to training manuals updated after each company. Japan has a drop in hourly flight time, a shortage of fuel even for laps, and the forced transfer of newcomers directly to units. Where the blues automatized firing short bursts at different speeds and angles, the whites had to hear the theory on the ground and pick up practice already above the front line. At the moment of the meeting, it turned into cold arithmetic. Who saw first? Who was on top? Who kept the speed and who knows how not to waste it? The 10th is the anti-aircraft environment. By 1944, the Allied naval orders had become floating fortresses. Long-range radar guidance, medium fighter interception, and short-range fire from small-caliber and medium batteries. Betty and Val could still catch someone off guard, but more often they were met by a multi-tiered network in which there were no holes. Even a successful breakthrough ended with the fact that the blow had to be struck in a hellish tangle of tracers, where any maneuver meant a loss of speed and altitude, and the exit was to meet the new 4 Corsairs. When all these layers were superimposed, the breakdown became noticeable not by heroic episodes, but by routine. The raid, on schedule, passed without losses. The interception attempt was foiled before the approach. The enemy airfield did not raise the planned group again. The convoy did not arrive. It was torpedoed at night in the strait. There is a delay in the batch of engines at the plant. There is no alloy, no coal, no electricity, and so it is every day. In this routine, the remnants of a comparable enemy force dissolved. Somewhere below, the aces were really fighting, but they could no longer turn the river back. The river became a conveyor belt. Corsair turned out to be an accurate instrument of an era where the system was winning. He was not the only hammer, but he struck where bundles of factors cracked. At train brakes, at fuel windows, on logistics bridges, at the minute when the radar calls right and down, contact for 1 hour. His speed translated more easily into initiative. His durability forgave mistakes, and his versatility allowed him to close the sky and break the earth in one takeoff. Therefore, when we say, what broke Japanese aviation, the honest answer is, the war of industries and procedures broke. The arithmetic of departures and tons broke. The disruption of personnel, fuel, and time broke. Corsair only brought this mathematics to a clear result, and this result could no longer be rewritten either by myth or feat alone.